Good evening, everyone. Myself Shlok Nemani, currently pursuing electrical engineering. Hereby, I am presenting my research done on the topic APY analysis for shrimps and seaweeds farming. I have outlined the following content in my upcoming slides. So, we will be seeing the shrimps and the seaweeds, the aquaculture and the associated UDA framework, the production prospects of aquaculture in the Indian Ocean region, the APY or area production and yield analysis, the environmental consequences of the expansion of the aquaculture in Indian Ocean region. First of all, let's talk about the shrimps and seaweeds. So both are biological marine organisms. Seaweeds are mainly categorized into phytoplanktons, while the shrimps into zooplanktons. And scientifically, there are numerous species of seaweeds and shrimps which vary in their internal constituency, and it also makes their biological study much more involved and in-depth because they have to be categorized into various families and classes based on their growth patterns, and that have to be considered separately. If we talk about the shrimps, the shrimps are mainly seen as a source of food. Various delicacies all over the globe are being prepared by taking the shrimp as a central item. Not only that, they also act as a energy source which are rich in proteins, omega-3 fatty acids, antioxidants, and vitamins and minerals. Coming on to seaweeds, so you might not find various use of seaweeds as a food, but they are seen as a food of the future because of their sustainable farming, and they are also used in the industry for the manufacturing of several value added products like pharmaceuticals because of their medicinal properties. Some of the cosmetics, they are also seen for their use in the feed of the cattle, and the manure from these cattle can be used for as a fertilizer substitute, which we will be seeing. They can be used as a biofuel or a bioplastic and can be seen in the wastewater treatment industry. Coming on to the aquaculture and the UDA framework. So these are the stakeholders which we have identified that are related most to the aquaculture. So coming on to the first one, that's the science and the technology. If we talk about the science, so science can be employed in the farming for a better future of the farmers and for a better growth of the economy. So if we talk about the scientific research or the biological research, so biological research on a certain organism have the capability to deliver the knowledge about the growth rate, the growth pattern, the reaction of the organism to the environment, the survival rate of the organism. All these can be studied from the biological researches. On the other hand, the technology, the development of the sensors in the current era, the rapid pace of development of the sensors, they can help us by providing the real-time data. This real-time data can help farmers for the real-time assistance of their farms, and they can even take the precautionary alerts to take any appropriate measures for their farms. The blue economy. So it's not just the word economy. And why is that? It's because it promotes the goal of sustainable development. The economy should not be, the growth of the economy should not harm the oceanic resources. And its main target is to provide the livelihood to the people who are most dependent on these resources. And the third is the marine environment and the disaster management. So the two questions which we have to ask to ourselves are how aware are we of the environmental consequences? Everyone knows that the every action has a certain consequence associated with it. So if we are focusing more on expansion of aquaculture, so are we aware of any negative environmental consequence? Are there any unforeseen consequences which we are not aware of? And how prepared are we for any disastrous events? So the disastrous event here means natural calamities or any widespread disease in the organisms in the aquaculture industry only, so which we are trying to focus upon. The production prospects. So this topic actually covers the motivation of why we are focusing on the aquaculture of the shrimps and the seaweeds. So first thing is that India is blessed with the geographical strength favoring the aquaculture farming of both shrimps as well as seaweeds. The temperature, water, salinity, and all the available geographic location. So these all favors the growth and the growth of the shrimps as well as the seaweeds. So if we talk about the 3 points on the left hand side, this talk about our strength, and on the right hand side, this talk about what our current status are. So if we talk about the strength, so India have around 11 lakh hectares land under the brackish water area. The brackish water is a water which is more saline than the fresh water. About the salinity of brackish water is about 10% to 32%, which is ideal for the shrimp cultivation. Even it can be checked from our APY tool that about 5 ppt to 15 ppt is optimal for the growth of the shrimps, and we have that in our geographic strength. And about 2.17 million square kilometer area under the economic exclusive zone extending from the coastal regions. So we have this much of geographic strength, but the area on the right hand side, we can see that the area under cultivation for shrimps is just about 1.1 lakh hectares. So that means only 10% of the total potential is being harnessed. So it shows the vast disparity between what we have in terms of geography and what we are harnessing. Second, in terms of technology, so we can say that India has a reasonably cheap data rate. So we all have a good connectivity at our homes, and even the data rates are not too high and can be employed. The technology using this connectivity can be employed. So this is the right time to even work upon these technologies, to intervene this technology in the farming. And thus, but on the other hand, we can even see that the India sharing fresh seaweed is about only 0.01%. So the reason of this may be about the study on the Gujarat, where it is shown that some of the farmers are not willing to grow seaweed because they feel they lack assistance in growing the seaweeds. So even with data rates, even with all the knowledge available on the internet, there are various documents from the government available on the document about the seaweeds, the growth of seaweed. Still we are lacking somewhere. So the reason might be the dissemination of the information is not being available to the farmers. The third thing, which is the launch of the Pradhan Mantri Matsya Sampada Yojana. So it is targeted to double the income of the farmer. So it improves the livelihood of the farmer, but it also promotes the sustainable aquaculture industry. So yeah, it is the most important thing that every industry should be made as sustainable as possible for it to be making the profits in the long run. But even on the right hand side, we can say that the friendliness, the technological intervention, and the digital identities of the farmers in aquaculture have remained low. The core of our research, that is the APY, or the area production and yield analysis. So the thing is to anyhow start to or to pioneer in order to intervene the technology in the aquaculture. So we are trying to optimize the yields, to study the patterns all through one tool, and that tool should be available to the farmers. So this whole analysis is bifurcated into two parts, because if we try to analyze it into one, so the better is to bifurcate into two parts where one is related to the other. So if we talk about the trends and pattern, so let's analyze trends and pattern through a flow chart. So on the top part, we can see that this APY compute tool, it takes the data from the MPDA, that is the Marine Product Exports Development Authority. So it takes the data about the shrimp production data, species wise. We have the data of the last decade on the basis of certain species. So we are trying to do five analysis with this data. That is the parameter visuals. The second thing, with the growth rate of production. So the growth rate is positive. It indicates that the farmers are willing to enhance their production. The growth rate, if negative, it means that in future we can see the declining trend of the production. The coefficient of variation. It is important to understand how stable the production, the area, or the productivity is in the last decade. Because if the variations are too high, that means the industry in that region is not stable. So this is the another mathematical parameter which we are working upon. Third is the area, production, correlation, and dependence. If the area and production are highly correlated or highly dependent, that means in near future, because area, we have already talked that we are using 10% area. So we have a we have certain amount of area which we can use to enhance production. But the area is not unlimited. The area is a limited thing, and to promote sustainability, the major use the area comes from that same area which we are trying to integrate into aquaculture. It comes from another use. So if we are trying to enhance area into aquaculture, the same area will be declining from the agriculture. So the main aim is to make production more and more dependent on the productivity or the yield, so that even with the same amount of area, we can enhance our whole nation production. And the last thing is the overall change in the area in the last decade, because we are also trying to see that since we are only using 10%, so we should try to enhance at least up to 20 or 30%. So we have to see that in the last decade, how much the area under the cultivation changed. So that brings to the first part of the APY analysis. Coming back to the our first previous slide, the second thing is the yield parameter relationship. So this is a pure mathematical relations which we are trying to establish, and it involves how to relate yield with the parameters. So these parameters are the environmental parameters, and if we try to maximize the yield, in that case, with the same amount of area, our production can be maximized. And with low losses, low waste in the industry, our whole industry can be made sustainable. So here, from the various researches, the biological researches, we are trying to categorize which factors affect the shrimps as well as seaweeds growth, trying to find some common parameters that can be integrated into one, and some different parameters which are not common to both, and trying to build the mathematical models, which is the second part of our APY analysis. So, like, let's try to understand what's the main benefit of our contribution. So, let's say on the top left, you can see that there are a lot of data. So that data cannot be understood directly. And even if one try to like calculate the parameters, so he have to first tabulate this all into an Excel sheet and make graphs and to tabulate using certain formula. But what if this all data can be fed to a tool that is managed by just like not too many are required, like just 2 to 3 persons which are there to manage this tool. So all these visuals, like we can see the visual of production, the varying production over the last decade from 2010 to 2021, and the production in Tamil Nadu, it increased by about 164%. That's the growth rate. The growth rate per year is about 164%. Similarly, the area under the cultivation in Tamil Nadu also increased, and the productivity can be seen as something sort of a constant. But yeah, the overall production in Tamil Nadu for the L1MA species have increased. So one can now see that it is too difficult to just see these numbers that are given on the web page. But if we have a tool that can give all sort of visualizations and all sort of calculations at one place, it will be too easy for farmers or the stakeholder to make certain steps that can be taken. If we see the obtained results about all the growth rate, about the tiger shrimp and the white leg shrimp or the L1MA shrimp, so we can see that the tiger shrimp showed the declining trend. So we can see that about Tamil Nadu. So the growth rate is highly negative. That means, and the similarly in the contrast, we can see that for the L1MA species, the growth rate is highest positive. So for Tamil Nadu, the tiger shrimp, the growth rate is highest negative, and for the L1MA, it is highest positive. So it indicates to us that the farmers of Tamil Nadu are either shifting to the L1MA because of higher returns or any other sociological reason or any geographical reason, that they are trying to figure out how the L1MA is more profitable to them. That's why the tiger shrimp showed the declining trend over all the regions, and in all the regions, the L1MA species have shown the positive trend. So let's try to concise all this into one. So we have certain conclusions that the growth rate parameter of the tiger shrimp has declined, while for the L1MA it has increased, and the wild shrimp, that is the scampi. So it was once, we can say that in the last decade, in the beginning of last decade, it was the major producer in the total exports basket of the India. But now the industry of scampi is it's just minimal in comparison to the Vaname and the tiger shrimp. Apart from that, the variations in these parameters are high over certain regions. So that may be due to the migrations in those regions, the switching of farmers to the other employment options. But this we cannot directly figure out because this data just tell us about there are some problems, but they don't give us the result that why these highly unstable variations are there in these regions. And the third thing is the dependence of production on the area. If production is highly dependent on the area, so that means that industry may not be sustainable in long run because the area is finite and the use of area should be in the sustainable manner. So the thing that drives us to the part of the yield parameter is to maximize the production with the maximizing the or optimizing the yields. So this brings us to the second part of the APY analysis, that is the yield parameter relationship. And if one can ask that, does the yield depends on environmental factors? So yes, we can see from various researches done on these both organisms, that is the shrimps as well as seaweed, that the biological factors of these organisms are affected by the surrounding factors. So these are the factors, the environmental factors affecting the growth pattern of the shrimp. These are the water quality of the pond, the temperature, the stocking density, that is the number of shrimps grown per square meter, the soil quality, the feed conversion ratio. The feed conversion ratio is actually the biomass of the shrimp or the biomass fed to the shrimp. the feed quality, how quality of the feed is good or bad, and the water clarity in which the shrimp is grown. Similarly, for seaweeds, we try to identify these parameters. Some of them are same, some of them show the contrast that are more important for the seaweeds. So the main focus will be on the sunlight intensity, the duration of the sunlight the seaweeds get, because their metabolism also depends on the photosynthesis and the light conditions. The skill assistance, as I have already explained, that some researchers showed that in Gujarat, the farmers are not willing to do the seaweed farming because they feel they don't have the required knowledge. And these researches, which we have make use of to formulate our APY tool and mathematical relations. So let's have a look on Viban et al. So they give about temperature and shocking density, but they did not give any mathematical model. So we are pioneering in making the formulations that can be used for the development of a whole framework. And they told that the optimal yield should be in 23 to 30 degrees. And our tool suggested that the maximum growth rate lies at about 29.1 degrees centigrade. So that shows that our tool can be used as a mathematical model to even show how good or how bad our parameters are. And that can even help farmers to optimize their farms. And similarly, the paper by Nawabi on salinity on the growth of shrimps, that shows that the salinity is important, but higher salinities. This APY tool showed that the salinity decreases quadratically with the increasing water salinity. So if the salinity is too high, the growth will be decremented as a square of the variation of salinity. And similarly goes for the seaweeds also about the pH, water pH, and the temperature and the salinity. The same relations and the same observations, and the tool formulations is different because the species have to be taken into account. And this is the our whole work, that how we are trying to establish the mathematical models. And the growth rate of the shrimp, the survival rate is important because only the survived shrimps can be sold into the market. And the growth rate with the varying pH showed that the basic pH is important for the growth of the shrimps. And these are the opportunities and limitations. The opportunities are the blue economy, as I've already explained, and the self-reliance. The farmers, if they have a certain tool in hand, so they are self-reliant. They can check their own farm, they can check their own parameters. The nation can harness the geographical strength. The work is now not only on the paper, because this work also employs the digital tool, the development of the tool, and the advanced researches like the application of machine learning or AI can now be built upon this whole work. And finally, the farmers which have the possibilities of higher yield can get higher investment too. So overall, their livelihoods improve, which is the main aim. And the main limitation in this whole research was the non-availability of structured data, because the data is available somewhere, and that is not structured. Because for any research, it is important, because the all the various researches today now employ the neural nets to formulate the models, but we don't have that to our disposal. So we have to try to use the curve fits, and using some only small amount of data. So there might be some error which will be removed if some effort would be made to conduct the on-site research that can get us some amount of data. And the thing to make this project a practical success would be to make farmers the friendly to the technology. And if we talk about the environmental consequences, because we have to comply with the blue economy guidelines. And if we talk about the shrimp aquaculture, so I would like to tell that, are we ignoring the long-term effects for the short-term benefits? Because the expansion of shrimp aquaculture in all the regions where the shrimp aquaculture has been expanded to a certain limit, it showed the prominent negative impacts on the associated region, like the biodiversity loss, the mangroves and the marshes, the freshwater crisis because of the salt intrusion into the soil, the discharge of the pond effluents. The pond effluents are acidic. The shrimp pond effluents are acidic, which are discharged into the freshwater resources without any treatment. The loss of land, because I have already explained, the land should be come from any other agricultural land or any other land, which can lead to the weakening of social relations, because the farmers which do the agriculture on their land may have the disputes with the farmers willing to do aquaculture. And finally, the water and the land use in aquaculture can show us the negative impacts, maybe even after a decade. Finally, does the same apply for the seaweed? So the answer is clearly no. As of now, there are no foreseen negative consequences, and even we can term seaweed as a pinnacle of sustainability. They act as a carbon absorbers because they use photosynthesis, so they absorb the carbon. They accumulate heavy metals from the water. They can be used in the cattle feed as they are nutrient rich. They trap essential amino acids from the water. They, from the process of photosynthesis, act as an oxygen generator. And the list is long because they can even be used as a biofuel. They can be used for the manufacturing of the bioplastics. They also absorb the nitrates and phosphate to support their own NP kinetics. To support their own life, they absorb nitrates and phosphate, and it is beneficial to us because it maintains the optimal level of nutrient. They can be act as a fertilizer substitute, and finally, some researchers show that they also act as ecosystem guards because similar to other vegetations, they also dampens the ocean waves. So these ocean waves, which are hitting the coastal region, they can be dampened by this seaweed. And finally, the thing why we are focusing on these two is that the shrimps, on one hand, are showing negative environmental impact, and such industry, the development of such industry cannot survive in long run because we have to also comply with the sustainable development of any industry. While the seaweed show the pinnacle of sustainability, so what we can do? Just we can see the possibility of integrating both the things, but the polyculture possibility have been shown in the paper, but there is a long path from the paper to the practical. So that we have to build so that the farmers can make use of that. With that, thank you for listening to my presentation. And so there it starts with the compute tool, and on the first page, on the index page, it mentions about the two domains and the two paradigms which I have included in my research. The first is the production trends, the APY trends, and the second is the yield parameter relationship. So the yield parameter relationship was the one where we have to develop the model, and here there is some theory about it, how we achieved the goal. So let's go to the tool. There we have two organisms, shrimps as well as seaweeds. So the idea was to classify both as a different species and to get the own set of parameters for each of them. So let's start with the shrimps first. Okay, so let's say if we talk about shrimp, so this is a most common shrimp species in Indian Ocean region. So let's say these are the parameters in the green boxes you can see. So these are the parameters which are important to determine the shrimp growth. Let's say the temperature currently might be, we are seeing nowadays the temperatures are increasing. So above optimal, we will be taking around 30. And for say the stocking density usually lies around 50, so we can take around 40. The salinity of brackish water we can get up to 20 ppt. The water pH, the nominal water pH by the farmers should be around 9. We are taking it as a 8. The feed quality, so this is a qualitative term which we have described as a what quality of feed we are taking. So let's say it's on the range of 0 to 1, it's about 0.9, which shows a good quality feed. Days of culture for L1MI, it is around 125. We can take 125 to 130. The feed quantity, we can take around 100 kilogram per hectare. So now it's computing. Let's check the result. Yeah. So this shows that the final weight of the shrimp. So all this computation is done in the backend. We get the results in our hand that shrimp weight after whole cultivation is around 20 grams or 19.5 grams, which is an optimal value. The optimal value for L1MI is around 21. So yeah, it's very close to that. So that means if farmer uses this all parameters in his farm, he is able to get good quality results or good quality yield from his farm. Total biomass would be around 728 grams per meter square. So in a hectare, it would be around 728 tons. That's about the shrimp. So this is the whole report about the shrimp farm.